everyone. Welcome to this third episode of this series where demo coding on the Amiga, where we will have our special guest Ozzy, where he will continue to explain how to make graphics on the Amiga. 3D graphics like what we are used to nowadays using OpenGL, but he has written something which he called AProcessing that gives features like OpenGL for the Amiga. Of course, not to that level of OpenGL. It's impossible, but it's a library that can give you those things. So, without further ado, let's continue with the usual ritual. So please like, subscribe to my YouTube channel. It's the only thing I ask, so that YouTube can decide to share my videos. I want to grow the Amiga community in coding, and it's the only way we can do this, by sharing our videos, my videos basically. Under each video, you heard me saying this, most of the time there are the chapters, so you can select the part that you like or you want to hear. But also there are the links to source code and information. So please do click that more button to see where stuff is. Many of you write to me in Discord where the source is or something like that, but all you need to do is click there and you'll see it. As you know by now, I have a Facebook page where all this stuff is there. Okay, everything that I do goes there. Same thing, I have the Commodore Dev Facebook group where anything related to Commodore goes there, and for some reason I think I forgot to do the Phase 101 Facebook group, so you can join that too. The page is my blog, or the website if you want to call it, where everything goes. I have my Discord. If you want to get in touch with me, please join there. Leaving me messages on Facebook, I do reply to them, but I take time. I had a message today, I saw it. I had a message, somebody asking me about Amos and the Scorpion engine. I replied today, but the message has been there for 2 days or so. So if it was on Discord, I would reply immediately. So I do not check Facebook every day. Also, the new Facebook is crap, I have to say. Luckily, the page still functions. And eventually I want to move also from Facebook when it comes to the page, because today the page is working, tomorrow I do not know. I'm dependent on Facebook. There is also my Telegram group. If you want to join there, it's only new, so there isn't much going on in terms of, there is 23 people, but what I mean is not so many messages because it's still new. But if you join, the more it grows, the better. Then you can unlock more videos if you join Patreon. I'm just saying because there are videos that you will not see on YouTube. I do have videos that I do not share on YouTube. And they are here, not all 68. Okay, so this is because I'm still releasing the videos of the book. But there are videos that you will not be able to see unless you are on on Patreon, and same thing on Coffee. They are identical. That's mainly it, as far as I know. Yeah.
Hello. 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 Good evening, everyone. Yes. Yes. Okay. Thank you, FaZe. So while you set up your code, I can try to just do a little bit of theory because it's needed to understand the code that later you are going to introduce. So I want to talk about a problem. One of the very first problem I had when I started coding on Amiga, so this craziness with assembler, and it is about decimal point representation on the Amiga. And this was a huge problem for me at the beginning because I don't know if I already told you, my background was C, maybe something in Java, so higher level languages. If you just need to represent a decimal number, you just type float x equal, and then you put your integer part dot decimal part, and that's it. And this is how it works on, I would say, every high-level language. But the Amiga is different. Again, you have to figure out something. And this is why I started researching different possibilities. Please go to next page. Okay, the problem, please represent the product, so the multiplication of two signed decimal numbers. And following, there is just a table, and it represents in my mind how a data register on the Motorola looks like. So as you can see, it's just 32 bits and nothing that could lead you to think, okay, I have to store a decimal part here or the integer part here. It's just data. All you have is this 4-byte raw data, and that's it. So for example, if you want to represent 0.5, how would you do? This was a problem for me because there is no bit for 0.5. You just have byte 0, so usually the bit 0. And so what you usually do is, okay, you multiply 2 per, you multiply for 0, and to elevate it to 0, you get 1, and then you get 2 elevated to 1, it gets 2, and so on. So this is how it works. So as I said, the data register just holds a 32-bit number with no information about the decimal part. And there is some dedicated hardware that help you to do this, and it's called FPU. And some Amigas, some high-end Amigas have FPU, and this is another completely different story because they store the number with doing some math and multiplication, the mantissa and the exponent. So this is how it works, but we don't have this feature in a stock A500 or even A1200. I don't think you need some sort of acceleration or a specific card to do this. Commodore didn't provide us out of the box with such a possibility. Maybe I'm wrong, but this is how it was for me in the 90s. Please turn the page again. Thank you. So there is this thing called the fixed annotation. So to make the programming simpler, we will use a fixed annotation format. We calculate the dot, separating the integer part from the decimal part, and we use a notation called Q format. So, for example, if I say I'm expressing a number in Q3.4 format, it means that I'm describing the number with 3 bits reserved for the integer part and 4 for the decimal part. So the last digit is the representation of the decimal part, and the other is the integer part. And this is above you can see some sort of how do I see my CPU data register. Of course, it could also be in RAM, but usually I do this type of operation in register because it's quicker, but it doesn't change the concept, the main concept. So here I said x equal unused, so it means that we are not using these bits actually, but of course they are meaningful because usually when you have a format like this and you have a 16-bit number memory area, or you just fill the x with zeros in case of a positive number and with 1 in case of negative. There is also a specific instruction inside the Motorola which is called x.w or the x.l, and what it does, it extends, so it fills all the bits to represent your number, and it's very useful. I use it all the time. So let's say we want to represent the number 1.5, let's say, for example. Okay, so you take the integer part, and the integer part is 1. So it's all you have on the left of the dot that is separating the decimal part from the integer part. So, and then 1 in binary is 001, for example. So you store 001 where you see the E, the I. Okay? Then there are on the right we have 4 bits that I marked with the D, and these are meant to reproduce, so to represent the .5. And so what you do normally here, you just say 1000 because that's the representation of a half. Because when 2 elevated to -1, it's just 0.5. So you just say you have to put the number over the bits, and so you say you usually say, okay, take the least significant bit and then multiply with this relative number, so it's 0.
So if we have 0.5, what binary will you write where the decimal is? If you have 0.5, 1.5, the 0.5, what do you write in DDDD?
In DDDD, you write 1000. So the final number will be a bunch of zeros, then 001, 1000.
So when you say 0.5, you're not referring to 0.5 decimal, but you're referring to 0.5 binary.
0.5 is the decimal representation. So
because
when
0.5 decimal is 101. So I expect
yes, but you are just doing the math for the integer part. Of course, if I say 5 point something, it's 101 because you do the multiplication and the addition.
Yeah.
So you say you do 4 plus 1.
Yeah.
But when you go into the negative part, so the decimal part, you have to use negative numbers as exponent. You can't use 0, 1, 2 as an exponent. You must do 2 and the power to minus 1, which is 0.5, plus 2 elevated to minus 2, and is 0, and so on. But I think in the next slide, I will do a real conversion.
Okay.
There are multiple methods.
Just for those that maybe I'm not sure if I had the microphone silent or not. I'm just because Ozzy can hear me, but if I had the microphone silent, you didn't. My question was if he can explain again the division between the integer and the decimal and how they are created. So now let's go to the next slide.
Yeah, for now, just remember that if I say Q3.4, it means just that 3 bits are reserved for the integer part and 4 for the decimal. Then that's it. And the Q format can be used, and I will, with the signed numbers. Just put the signed bit into the most significant bit, and in case of a negative number, just use a 2's complement. So this is not something new because probably you already know that the Motorola can interpret the number as a positive or as a negative, depending on the instruction that you are using. For example, if you use mults, and this is a signed operation, it means that the most significant bit represent the sign. 0 is positive and 1 is negative. And you probably also already know that if you want to represent a negative number inside our Motorola register, you have to do the 2 complement. And the 2 complement, it's a very easy operation. You just do the 1 complement and you add 1. So it just needs some Boolean operation here, but it's not so hard. So for example, the number plus 5, as I already told you, in binary is 101. If we want to represent minus 5, we must invert its digit, so the equivalent of the not instruction, and it becomes 1010. Then you just add 1, and that's it. You have your result, and this is quite straightforward. And all these rules still apply when you use this Q format. And there is also this very nice website that I often use while doing calculation, just to see if everything is okay, which is rapidtables.com.
Can you share the link in the chat of Twitch?
The HTTPS semicolon rapidtables.com, and here you can convert from decimal to binary or to hexadecimal, and there is also a small section. I think there is some censorship in Twitch. I can't share links. I don't know.
You should be able to. Can you send it to me on Telegram and I can share it?
Okay.
Oh, I'm creating you problems now.
Yeah, because I have Telegram here. Rapid tables.com, Telegram. Okay, it's sent, but it's just a simple converter. You can use your own calculator or whatever. Even the Motorola can do it. So it was just a refresher how to use negative numbers on the Motorola, and this should be quite easy. Please turn the page.
Before you continue, can I ask you how many examples you have for today? Four?
Four.
So the first four.
So are you referring to the code examples?
Yes.
Yes, only four, but they are very similar to each other, and they are
because you sent me 8.
No, I sent you 4.
No. Then it's the same code of last time that I'm editing.
Yes, I sent you. I can send you again. Maybe I'm mistaken.
You sent me 8 for sure.
Okay. Let me check. Flash 20. Is third episode. The file is third episode.zip. I will send you all this stuff in Telegram.
Yeah.
It's 5 megabytes of stuff. I think, okay, you received it.
Okay, I'll start again from the beginning.
Yeah. So in the meantime, I can continue my example.
Yeah.
So let's say we want to represent this very strange number, which is a equals 9.21795, etc. So this is my method, but there are many others, of course. To represent the integer part, we just need 4 bits because 9 is between 8 and 15. So 4 bits are enough to represent 9, which will be 1001. But I want to represent also the sign, so I need an extra bit. So the final format that I will use in this case will be Q511. Of course, Motorola register are 4 bytes, but what I usually do, I do calculation only on the word, at word size, because for the Motorola it's better, and you have a performance boost if you just need to operate in a word, because it needs more cycles to perform operation on long words. And so this is why I always use 16 bits. But anyway, to get the binary form of this number 9.21, etc., what I do is I just multiply the number for 2 elevated to 11, and 11 is the number of digits that I use for the decimal part. So you perform the multiplication with your calculator because it's very long to do it by hand, and you end up with 18876.3288, etc. Of course, we don't have so many bits to represent the number, and we will need some sort of rounding, because in order to represent this number, we will need much more bits reserved for the decimal part. So when you round it to the nearest integer, you end up with 18,876, and you do the conversion of this number in binary, which is also something that machines are much better than humans. So the binary that you get is the Q5,11 format. You just know that there is a point after 5 integer digits, and that's it. This is what you have to write on your data register. I think that is quite easy. I don't know if I explained it properly, but it's very straightforward. You just take the number you want to represent, you multiply by 2, elevated by the decimal part, the decimal digit, in this case 11, and you do the conversion in binary. And very easy. Of course, I don't do this by hand. I just use a calculator. But this is important to know because what I'm going to explain the code will use this stuff. And it's important that you understand this before jumping into the code. Please proceed with the next slide. Okay, as I told you, processing uses, so my libraries, my function are using different Q formats depending of the situation. When using scale, which is the subject of this, let's say, this presentation, we must provide inputs in Q10.6 format with sign. And this is a choice that I did by design because I liked it, and I thought that it should fit well on my situation, because when you scale something, you must use something like a decimal number, because if you want to shrink a figure, you have to multiply by something that is less than 1. If you want to mirror it, you have to multiply with something which is less than 0. And if you want to enlarge it, so to swell it, you have to multiply with something greater than 1. So I have to provide my routine all these different numbers according to the situation. And so I need to represent signed numbers. I have to represent decimal numbers and integer numbers. And it's better to represent in words because I will perform multiplications. So since I know that if I multiply two numbers, two words, the final product, the final result will, I'm sure that will fit on a, for example, D0 register because it's 4 bytes. And I won't get any overflow. Of course, on the downside, you can't represent very high numbers because I only have 10 bits to represent the integer number. So one of these 10 bits is reserved for the sign. So you end up just with 9 bits and you won't go very far with these 9 bits, but to represent coordinates or scaling factors, for me it's more than enough. Of course, if you have to represent, for example, the sine of x degrees, I would prefer to increase the decimal part because the sign is something that goes between 1 and -1. So I don't need to have 10 bits to represent the integer part. So this is why for this particular application, I picked the Q10.6 format.
Is this standard? Is this a standard or something that you picked?
No, this is not. This is something that I figure out on my own because I said, okay, I want by design my routine will behave like this, and they are meant for Amiga, and Amiga PAL is this resolution, so I don't have the maximum that I will have will be for example, 255 for the vertical and 320 for the horizontal resolution. So I don't need to multiply, for example, 1,000, 1 million. Just need to stay within this. And so I picked this format.
Okay.
So I will say that's it. I think the slides are over. Go to the next one.
Yeah, this one.
Yeah, go turn the page.
Yeah, I have this one, example 1.
Yeah, at this point I'd like to go into the code.
Okay, that's what you mean. Yeah. Now the code, because I had the previous one, I need to close everything again and open it again.
We have time.
Yeah.
As you can see, today I'm very quick. And
but I want to jump back to those slides because there is one slide I want more explanation personally.
We will do it. But I think reading the code, everything will be more clear to you.
So.
1. AProcessing.
Yes, it's 1.
Don't you have lezione 8?
No, the header will not show it.
Okay, this is 1. So this is the very same example that, if I remember correctly, it was just drawing a square on the center of the screen. And it was rotating last time. I don't remember what I did, but something like that. I remember a square. So please scroll down and find where there is the.
Yeah, I just started my Amiga machine. Yeah. So where do you want me to go? This part?
Just scroll down where there is the loop. This is always the same stuff. Here I drew the line just as a reference.
Okay, so here.
Okay, go scroll down again. Oh, stop.
Yeah.
So there is this jump to the square function again. And just a reminder, the square routine draws into the bit plane a square at position -10, -10. These are the x and y coordinates of the top left corner. And 20 into d5 is the size of the square. And of course, the square is printed at the center of the screen because we just moved the origin with the translate routine before. As you can see, there is a move.w width divided by 2 and into d0 and a height divided by 2 into d1 and the call to translate. We have already seen all this stuff in the previous episode, so nothing new. What is new is the scale reg routine, and what the scale routine does, it changes again the plane. So we are changing the plane 2 times. The first one, we are translating into the center of the screen. We are saying, okay, the 0.00 is no more on the top left of the screen, but it's in the center. And then we shrink. So let's say we scale, it's more general. And the scale function takes two arguments. We are passing values by processor register. The first is a bunch of zeros and then 1 and a bunch of zeros again. Why is that? Because, as I told you before, I am using a Q610 notation. This means that it's a Q10.6. So it means that the last 6 bits are reserved for the decimal part, and all the others are the sign and the integer part. So it's clear now that on this 0 we are storing the value 1. Is it clear? This and on D1 we are storing the value 0.5. So it's a decimal, only the decimal part. So what we are asking is to translate to change the plane and to let's say shrink vertically, because the D1 represents the vertical shrink. We are just shrinking by 0.5. And this is the result will be a square, which is no more a square. It should be something more like a rectangle right now, because the height will be half. Are you able to run this code, Phase?
Give me a second.
In the meantime, I need a bottle of water.
Mine is not called. It's called just Vesim.
What?
Mine is the Vesim is called Vesim, not Vesim_MOT.
Oh, sorry.
Yeah, it's
My
okay.
fault.
No, it's okay.
No.
I just need to edit that. Did I save it? Yeah. Okay, so now we can bring the Amiga. Just going to move it down here. So let's make it squarish, because it's not. Don't like it when it's not. Okay, so we assembled it, and we should run.
The name of the file is always the same.
Yeah, this is why it is confusing, you know. Okay, there you go. It's not a square anymore.
Should be, I hope.
No, it's not.
Okay, I added some extra lines, as you can see. The horizontal line on the top is plotted at the center -10, and the bottom one is the center +10, just to make more, to highlight the fact that the height of the square is halved. It's half of the original because of the scale function. So, for example, you can try to double it. For example, just edit the file, edit the code, and change what goes into D1.
So, what do you want me to do here?
Close the emulator, or at least we need to...
Okay. I removed it, yeah?
Yeah, this one. Based on what I said before, you should be able to represent the number 2, for example.
Yeah, but because I was editing your files, I did not follow you, my friend. So now you have to tell me.
I will repeat, no problem at all.
Yeah, that's why I told you I would go back to what you said, because I did not understand, because I was editing your files.
Okay, do this. Highlight the last 6 digits of the immediate number that I'm storing into D1.
Yeah.
The last 6, okay? And this is the decimal portion of course, okay? Just to make some order, put a space before the 1. Just
to understand,
yeah, to better understand.
Yeah.
Of course, we will remove it later. So, what you have on the left is the integer part, and what you have on the right is the decimal part. So, what I'm asking you now, forget about the last 6 digits on the right, type 2 on the left part.
So
it will be a 1 0, and that's it. Okay, exactly, this is 2. So we want to represent 2.0. So on the right part we just 0 everything. So replace the 1 on the right side with 0, and this is the 2 number in format Q106. Okay, now you remove the space and compile. So right now you should be the height of the square will be doubled. Hopefully. If it doesn't, it means my code is not working.
Of course not. Hold on. Yeah. Hold on. You know, if I save, it would help.
Yeah, you have of course to save the point, the dot, the white dot on the top of the screen.
Okay.
Is telling us.
So now, let's run it again. There you go. Double.
Nothing?
No. It's double.
Oh, okay. It's double. So it looks like a rectangle, but rotated by 90 degrees.
Yes.
So it was just to explain what we are doing right now. We are just changing the size of a figure on the screen. And we are doing not changing the coordinate of the vertices, but we are doing just changing the plane, how the plane is done, essentially.
When you say plane, can you explain exactly what you mean by plane?
We are just doing a plane transformation. When the routine is drawing the primitive, so in this case it's the square, it multiplies each vertex with a thing which is called transformation matrix. And the transformation matrix was altered by you 2 times, and with translate and with scale. So you are imagine that you are drawing a square into a sheet, and you are stretching vertically the sheet, and of course, as a consequence,
Okay. Yeah.
the square will be
Stretched. Yeah.
stretched as well.
Mhm.
So this is the same concept.
Okay. Fair enough.
We can proceed with the example number 2, which is almost identical. I
Just
think.
one thing. This slide. You had a slide for example number 1. Do you want to explain it?
It's just the same stuff that I have just described.
fair enough.
Just let me give a look what I wrote because I don't remember.
That's what you have written there.
Wait, there is some sort of delay. Okay. Scale the square vertically by 0. We are shrinking it. So, and this is a copy and paste of the relevant part of the code. And what is important here is to understand that into D1 we are storing the value 0.5 for Y scaling. Okay, and then I press right mouse button to not scale. You can run it again and
Yes.
press the right mouse button to see the difference between the original plane
There you
and
go.
yeah, this is the original square, and when you release the button, you should see the stretched one. So this is how it works. The difference. Yeah, nothing exceptional, but I'm glad it worked.
Shall I? Do you want me to pass to the second example or to the slide?
Just go to the second example. Yeah. I think you can copy your batch file to the new directory. Should be the same. But just to make sure, just to replace your comments.
Yeah,
maybe.
just it's not a big thing. I'll just replace this. So this is the second one, and assume you want here now.
Okay, there is the same exact section, and so what's the difference here is that now we are multiplying, we are stretching the x-axis, the x values, because is in D0 we have, I think, the number 2, and in D1 we have the number 1. Again, same exact format, so the last 6 digits are the decimal part. You can run this and see the very same square stretched horizontally. Hopefully.
There you go.
And that's it. And of course, you can press the right mouse button to see
What is the
again.
difference between this one and the previous one?
Please, can you repeat? I didn't.
what is the difference between this one and the previous example?
The difference is that before we were stretching along the y coordinate,
So it's along the x-axis. Okay.
and this one is along the x.
Where
Yes.
did you specify that it's going to be along the x-axis here?
Because we can stretch both horizontally and vertically.
Yeah. Where did you the parameter to say we want the x to be stretched? Where is
It's
that?
move.value, it's line 100.
100 and sorry, because you cut off.
112.
So it's the other line, it's the 0.
This 0. Okay, you just add another one to the left, and you will see that it will go even bigger.
Okay, so
Okay, what number is this? Just put the space
4, no?
like before.
It's 4 now, no?
Yes, it's 4. So now we are stretching the x-axis 4 times.
Yeah.
So if the square is size 12 pixels, now it should be size 12 per 4.
Yeah, there you
multiplied by 4. So 80 pixels.
Yeah.
And I trust my engine. I don't count pixel, but should be reasonable.
Okay. So that makes sense.
Okay, go to next. Next.
Do you want
example.
to see? Remember your slide?
Oh no, doesn't matter because
No.
It's always the same. It's just a copy and paste of the code.
Okay, fair enough. So.
Yeah, it was just painting in red the decimal part. So I don't remember what we are doing. Okay, this is just an animation. This time we are scaling dynamically according to some variable. Okay, and go up just a little bit. Okay, stop. So until translate, it's always the same. Then
okay. Like this part then.
Yeah, the difference here is that I introduced two new variables. One is called increment and one is called counter. So what I do, I put counter into the 0 and the 1. And then I compare if it's 1, I think that number is or 2. Okay, it's 2. So, and I increment. So it means at the first iteration, it will have 1. But not 1, I'm not referring to 1 as an integer, but the D0 will be 0, 0, 0, 0, 1, which in the Q6, Q106 format will be, I don't know, 0 dot something, very small number. Then will be something that something more, and it will reach 2, and then it will decrease again. So you should see something that is swelling, so it's enlarging, it's scaling up, and then when you reach 2, it will scale down toward the 0. because into the when there is the next label, we are testing against 0. tst.w is telling us if the d0 is 0 or not, comparing against 0. So if you run this, you should see something scaling up and down, up and down. Some sort of animation.
Yeah. Cool. I'm starting to like more and more your framework, my friend.
So I have a question for you.
Mm-hmm.
What does it mean, according to you, to scaling by 0?
Scaling by 0 remains the same.
It means to not draw anything, because
Yeah.
if you multiply something by 0, you get 0. So 0 pixel, you don't draw anything.
Mm-hmm.
You just, but on the contrary, if you are scaling by 1, you are doing what? You are doing nothing, because each vertex will be multiplied by 1, and the final result is the same vertex. So
yes.
you are not scaling, actually.
Yes.
So I think now you are starting to understand why I needed the decimal part representation, because if I want to shrink, I must give a number between 0 and 1. And this is why I started with all this mess, all this Q format and fixed point notation and so on. So this was very important for me, because without this knowledge, you can't understand what is going on, actually. Another question, what does it mean to scale with a negative number, according to you?
For me,
Yeah.
You're making it smaller.
No, the minimum size is 0. So if you multiply by 0, and the square will be size 0. If you go to, for example, minus 0.5,
yeah,
what will happen is that the square will be flipped. And I think we will see in the next example. But if you multiply, for example, the x by minus 1, the size will be the same, but the vertices will be flipped. The right part of the square will be on the left, and the left, like if you are seeing it through a mirror.
I cannot imagine that happening. So that's very it's beyond me right now to imagine that happening.
Okay, let's try with next example. Maybe it will be more clear.
Okay, so let's exit from here. And let's load the next example. So guys, if you want to do demos, okay, for the Amiga, I think this framework is a really good start. Even if you do not understand the thing like me, I think it starts making sense if you follow the principles that Ozzy is sharing with us. To understand the code behind it, it's a different story, but at least if we understand the principle, it's a start. And that's what I am at least trying to achieve. Because once you understand the principle, you can always, from where to start. But when you do not know the principle, you don't know from where to start. This is what I always say about assembly. When you know what needs to be done, no matter how big it is, you are able to achieve it if you know the principle of what you need to do. But if you don't know, you cannot. Do you want to explain the code, or shall I run it?
Just run it because it's always the same. If I remember correctly, it's just a triangle instead of a square because I was bored.
Uh-huh.
And
With it
I
more.
think this is my last example.
Yes, it is.
But we can play with it a little more.
Cool. But I'm still not understanding the mirror effect. What do you mean by mirror effect on this?
Okay, now it's not so obvious because the triangle is, how do you say, it's the same. So, but if you watch closely, you will see something like a triangle is rotating along the y-axis.
I see what you mean.
Okay,
Yes.
of course this is not a real rotation because what we are doing here is just telling the scale function to shrink, to scale up and down, but the final effect to me is something that is rotating along the y-axis.
Yeah, if you look at it closely, that's yes, I agree.
But I would say let's try to make it more obvious. Go to the code and find the section when I define the vertices of the triangle. I will say it's JSR triangle. Okay, for example, at line 100, and let's do it like I did before, while I was waiting. Wait. Okay, triangle. Okay, at line 149, you just change the 50 into 100. Okay, so this is the third coordinate of the triangle. So the triangle will be like irregular. We call it scaleno in Italian. I don't know in English.
Yeah, so this is what happens though.
It should not, but yes, I don't know. Because yeah, let's do this. Go to
because of the line, probably.
Yeah, because of the line. Because long explanation here.
Yes, because I know the splitter, so I know that that it's doing it because of the line.
Yeah, exactly. Just remove the line and you should see the triangle. It should be at line. 98 and 99. You should have to comment it
Yes.
out.
So I can remove both of them.
Yeah. And
Yeah, exactly.
okay, but what I so now the rotation is more evident, I think, because we have an irregular.
Yes.
But the problem here is that we are not doing a full rotation because we are stopping at 0.
Mm-hmm.
So we can do it better and try to do a full rotation. So go into the code and find the next label.
Next label. Yeah.
It should be at 123, for
Yes.
example.
Yeah.
Okay, you just comment the test instruction. Okay, now you type instead of test. No, don't compile. It's not done yet.
Yeah.
You
Okay.
just type move instead after test.w. You do move.w
Mm-hmm.
and you move the value that you have at line 118. So it's 0, 0, 0. Yes, that one. And you copy on, for example, on D4, which is free. Okay.
Should I save?
No, wait. After moving, you could type neg D4.
Neg.word.
No, neg.word. It's okay. And neg.word. And then you type cmp.w D4 D0. Okay, and why I did this? Because this number, this 0, 0, 0, 0, 1, etc., is 2. Okay, and we store it into D4, and now next we use the neg instruction. The neg instruction performs the complement, the to complement, and so you get -2. So you have this iteration that goes from -2 towards 2, and then it goes back to -2. So we are scaling towards 2 at the beginning. So the triangle is growing larger on the x scale. Then when we reach 2, the value of 2, we are starting to shrink, and at one point we will be at 0, and when we have the 0 value, it's like if the triangle is completely hidden because it's pointed toward us. It will be just pixel. And then we go into negative territory, so minus 0.1, minus 0.2, until minus 2. And in this portion, the triangle will be flipped, like if we are seeing through a mirror, as I told you before. So if everything is okay, you can compile, assemble it, and run it. And I hope it will work. Otherwise,
Oh yeah, but look what happened. It went, what you call it?
oh, yeah,
Outside.
there is something wrong here. But it doesn't matter. Probably there is something I did wrong on the code. But you can see that when we are in negative territory, the triangle is flipped, as if we are seeing through a mirror. And this is just what I wanted to demonstrate. If you are scaling by 0, you are not seeing anything. So it's just if the triangle is pointing toward us, toward the screen. So this is not a real rotation. It's just some trick that I use to perform rotation on the x-axis without using 3D routines. And it works. I don't know why it doesn't right now, because it's not stopping at the right moment. It should stop at minus
Yeah,
2,
so
but it's going
you're
far
getting,
beyond.
you're going outside the board, and then it's like
Yeah,
bouncing
because
back.
it's not stopping at minus 2 for some reason.
Yeah. So
I can send you the file, the correct file, and see what's wrong. Let me check, but it doesn't matter. The important thing is that you understand the concept here. It doesn't.
yeah. For me, it's clear what it's.
It really doesn't matter because it's not working. The important part is that understanding that going into negative territory, it means flipping the image. And that's it.
Okay, so I assume this was the last example, no? So
Yeah, sorry, because this time I didn't have time
well,
to do much
we
more.
did more than 1 hour, so it's quite good. So I need to find someone to raid, no? So guys, first of all, let's thank Ozzy for his info about demo coding using 2D. Right now it's all 2D, right? We're not doing 3D. Things that you see in demos. And of course, we're pretty sure Ozzy will be going into more depth about the subject. Okay, guys, thank you very much. Thank you very much, Ozzy, for your help so far. Hope to see you in 2 weeks' time, and you'll have better time to prepare because I know you had a med week. Yeah, see you in 2 weeks' time with Ozzy. Bye bye.
Bye bye.